As erosion continues, the machine controls advance the electrode through the work, always maintaining a constant gap distance between it and the workpiece. To understand how EDM removes metal, let's examine a single spark in the erosion process. As a pulse of DC electricity reaches the electrode and part, an intense electrical field develops in the gap. Microscopic contaminants suspended in the dielectric fluid are attracted by the field and concentrate at the field's strongest point. These contaminants build a high conductivity bridge across the gap. As the field's voltage increases, this material in the conductive bridge heats up. Some pieces ionize to form a spark channel between the electrode and the workpiece. At this point, both the temperature and pressure in the channel rapidly increase, generating a spark. A small amount of material melts and vaporizes from the electrode and workpiece at the points of spark contact. A bubble composed of the gaseous byproducts of vaporization rapidly expands outward from the spark channel. Once the pulse ends, the spark and heating action stop, collapsing the spark channel. Dielectric fluid rushes into the gap, flushing molten material from both surfaces. This EDM residue consists of small solidified balls of material and gas bubbles.
Making parts with highly detailed, extraordinarily tough shapes and tight tolerances can be nearly impossible with conventional machining techniques, but not with a wire EDM process. Imagine being able to make precise cuts in metal with a blade no thicker than a human hair. That's what wire EDM can do. EDM stands for Electrical Discharge Machining. But instead of a blade like a bandsaw, wire EDM uses an electrically charged hair-thin wire to remove microscopic particles and shape the part. These animations help show how wire EDM works. The wire carries one side of the charge, conductive material carries the other side of the charge. And when the two get close, a white-hot electrical spark jumps the gap, melting away tiny dust particle-sized pieces of metal, 2 microns or smaller. How small is a micron? Well, if this was the diameter of a human hair, this would be a micron. But what's all this liquid? Well, that's the dielectric. Deionized water, really. Useful because it doesn't conduct electricity. In wire EDM, the liquid dielectric controls the sparking, cools the process, and flushes away those tiny particles as they're removed. All very fast, about 1 million sparks per second. The particles themselves are each about the size of a particle of smoke. In the right hands, wire EDM can be used to hold really tight tolerances, create incredibly complex shapes, work with difficult materials that may be extremely hard or soft, and if needed, make really small parts. There's even something called small hole EDM for working from the inside of the hole to the outside. All completely automated and CNC controlled. No human involvement. At Exact, wire EDM is all we do. We're very good at it, making us the perfect wire EDM partner to produce complex precision parts that often can't be made any other way. Like this. Looks like one part? It's really 2. And this springy thing is just one part.